already have this piece of paper. From there, you're going to take the scissors and you're going to cut it into this piece, and then this piece. So 3 pieces all together. And once you've done that, you're going to go to the next empty page in your journal. We're going to call this Dilations, and we're going to glue this stuff in. This is not going to fit unless you fold it, so if you want to fold it like that, you can, or if you just want to straight fold it in half, that's also fine. Whatever works for you, as long as you still get that in there. Okay, so now we're ready to proceed. I'm going to zoom in here so that you can see a little bit closer. So we're going to dilate triangle ABC by a scale factor of 1/2 within the origin as the center. This is what we're doing. So let's find the pre-image here, coordinates. So point A is 2, 1. Point B is 2, 5. Point C is 5 and 1. So then to dilate it with a scale factor of 1/2, I multiply each coordinate by the scale factor 1/2. So 2 times 1/2 is 1. 1 times 1/2 is 0.5. 2 times 1/2 is 1. Half of 5 is 2.5. Half of 5 is 2.5. Half of 1 is 0.5. And so now we're going to graph it. And I'm going to zoom in a little bit tighter so that you can see. Alright, so A prime will now be at 1 for the x. And my little point there got lost. So 5/10. So here's 1, and then we're going up 5/10 for the x, or half, and this is A prime. B is over 1, but then up 2, and then a half. So this is B prime. C prime is 2.5 for the x, but then a half for the y. And there is C prime. We're going to connect those dots. There we go. And I'm going to change colors. For the second one. Triangle ABC to triangle A double prime B double prime C double prime. So our directions down here say to dilate triangle ABC, so back to the original black pre-image, by a scale factor of 2 with the origin as the center. So what's cool here is the pre-image coordinates are the same. So I'm going to save myself some work, and I'm going to go up here and steal the coordinates from my pre-image. So there's less work for me to do. Now this time my scale factor is 2, so I'm going to multiply 2 by each of the coordinates. So 2 times 2 is 4. 2 times 1 is 2. 2 times 2 is 4. 2 times 5 is 10. 2 times 5 is 10. 2 times 1 is 2. Now I'm ready to graph. So A double prime is 4 for the x's, and then 2 for y's. So this is A double prime. I'm going to draw an arrow in there. A double prime. B double prime is 4 for the x's, and then 10 for the y's. So here's 2, 3, 4, 5, 6, 7, 8, 9, 10. So it goes all the way up to the top of this coordinate plane. This is B double prime. C double prime. 10 for x's. So start at origin. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the x's. 2 for the y coordinate, so up. 1, 2. And here's C double prime. And I'm ready to connect my dots. Something that I would like to show you, and I need a straight edge for this, is that, and this is particular for specific to dilations, is we can line up our corresponding points. So I'm going to line up all the B's together. And when I do that, look what happens. I'm going to change colors here. Now I'm going to line up all my A points. Here's A. And there's an A, and there's an A. So if I line up all those together. Alright, and then last one, the C's. C with C with C. What you find is your center of dilation. See how they all connected to that center of dilation? Which for this one was my origin. So your corresponding points should be in a straight line together from the origin, or your center of dilation for this. So another thing that I'd like to show you is we're going to compare the side lengths of these things. So on the original, the pre-image, side length AC is 1, 2, 3 spaces. Side length AB is 1, 2, 3, 4 spaces. We're going to compare that against, we're going to use the orange one. And we can only count the lines that go straight horizontal or straight vertical. So let's compare it with A double prime to C double prime, and A double prime to B double prime. So the length of A double prime to C double prime is 1, 2, 3, 4, 5, 6. From A double prime to B double prime, 1, 2, 3, 4, 5, 6, 7, 8. So from 3 to 6 and from 4 to 8, you can see that the scale factor is 2. So that's one way that you can use to find your scale factor if it's not given to you. You can count the side lengths from the pre-image to the image to determine, okay, from here to here I multiplied by 2. So that's one of the ways that you can get your scale factor. So after that, we're going to we're going to do dilate triangle JKL by scale factor of 2. So go ahead and list the original ordered pairs and then scale factor of 2 and do that. Do the same thing for this one, except this time you're going to use a scale factor of 1/2. And then this one, it gives you the pre-image, it gives you the image, and it asks you what's the scale factor. So use your coordinates to help you determine the relationship between these two and figure out what the scale factor might be. So now, after all of that, comparing your pre-image that's in black here to your image, your first image that's in blue, and your second image that's in orange, on the next page, and we've started this in class, and here goes all the ways that you can identify that the pre-image and the image in a dilation are the same. On the outside circles from pre-image and image, this is where you make the list of how they are different. And then we'll compare that in class. I'm going to zoom in real tight here so you can see. Double check what you've got here, particularly the coordinates. And some of this, when I copied it, it got cut off. So my apologies. J is at -3, 6. K is at -1, 1. L is at -3, 1. So after we dilate, we've got a scale factor of 2, -6 and 12, -2 and 2, -6 and 2. Now you can't really graph J prime very well here because it goes way up off the paper here and off the grid, but we can get -2 and 2 for K prime, and we can get -6 and +2 for L prime, and J prime is just going to be way up here somewhere. So fix that if you need to. All right, for the middle one, we started off with A at 0, -4, B at 2, 0, and this is C at 4, -4. Then our scale factor was 1/2. A prime ends up at 0, -2. There it is. B prime ends up at 1, 0. And C prime ended up at +2, -2. So +2, -2, there's C prime. So then the last one, this one was a little bit more difficult because it goes off the grid here, and this is slanted, it's not straight vertical or horizontal, so that made it more challenging to figure it out. So Q starts at -4, 1, R starts off at -1, +4, and S starts off as -1, 0. Now the only one that's straight out identifiable, because R prime's way out here, Q prime's way out here, I can't really identify exactly where those guys are right now. I can identify S prime. It's right there. So obviously we need to touch on, this is the image because it's got the primes. This guy, this little guy here, is the pre-image. So looking at -1 to -2 and 0 to 0, the scale factor here is a 2. Another thing that you can do, and this is, again, it's hard because R prime is way out there, is you can use this as an informal measurement of, okay, here's the length of S to R, so how many times can I fit that? So I'm going to take that little dot and move it up to there. How many times can I fit that on that side length? So that's 2 still. So a scale factor there would be 2. Now that we know that, we could fill this in with -8 and 2, and then -2 and 8. That's all we have for today. Thanks for listening.